A warm welcoming to you this time of the hour, this evening. I hope everyone is embraced. I hope everyone is protected. I hope everyone is safe. Lately, we received questions on trigonometry, and we figured that we have to cover trigonometry today. So today we're gonna start our trigonometry. I'm gonna take you from grade 10 to grade 12, but I'll be doing a summary first so that you can have an overview of what's really going on. So that we can be able to move together when we are doing more questions. So that we can be able to move together when we are doing more questions. Trigonometry. Let's just wait for until 1805 so that you can see maybe one or two people also will join us so that we can proceed with our today's tutorial for trigonometry. Trigonometry. It carries 40 marks in our maths paper 2. It carries 40 marks. Please don't forget to subscribe on our YouTube channel, Yebo Tutor. Also, please don't forget to comment on the comment section. Please don't forget to join our group. Don't forget also to join our Facebook account, which is Yebo Tutor as well, so that when you have fast questions which you are struggling in, we can be able to respond to you in time and be able to assist you in time. Please make it a point that you subscribe so that whenever we are live, you can be able to get the notification. And don't forget as well to hit that notification bell. Please don't forget. So today, okay, let's just wait for 1 minute more. 1 minute more. 1 minute more. 1 minute more. No. One minute more. Epic. Now let's start with our session for today. I'm going to try to summarize everything before we go for questions so that at least we have an overview which is a bit easy and straightforward. Now, looking at the topic of trigonometry, we started to have trigonometry in grade 9 and we were taught in grade 9. So the grade 12, in order for you to understand trigonometry grade 12 and also grade 11, you must also have the basics of grade 9 and grade 10 as well as grade 11 for the grade 12 students. So it's so essential that you know those things because they are so important. Those important terms which we use, they are so much important. So now, without wasting much time, let me take you to grade 10. In grade 10, we were taught about the three trig ratios. So we have the three trig ratios, and the first one which we have is the sine ratio. Others say sine, the sine ratio, the cosine ratio. Sine ratio, let me just say sine of theta. Theta is the angle. Number 2, we have cosine. We have cos of theta. Number 3, we have the tangent, tan theta. So these are the three trigonometric ratios which were taught in grade 10. Now, We apply them now, having a right angled triangle. Let me just say this is our theta here. This is our x, this is our y, and this is our r. Now, having this right angled triangle, we know that according to the hypotenuse theorem, we know that r squared is equal to x squared plus y squared. So in other words, x squared plus y squared. We only use the Pythagoras theorem, sorry, if we have a right angled triangle. Nevertheless, you can't use the Pythagoras theorem if you are not given the right angled triangle. So in this case, this is our right angled triangle. We know that sine of theta is opposite over hypotenuse. We know that cos of theta is equal to adjacent over hypotenuse. So let me just highlight this as well on our table. So this, okay, let me just draw something here next to us. Let me say we are having this the xy plane, and we are having it in the first quadrant. Then we have our 90, we have our theta here. This will be our adjacent side. This will be our opposite side. And this will be our hypotenuse side, say x, y, and r. So sine of theta, it's opposite over hypotenuse. Cos of theta, it's adjacent over hypotenuse. Now going to number 3, we have the tan of theta, which is equal to opposite over adjacent. Opposite over adjacent. So this was grade 10 stuff. It was not that hard because it was something which is like this. So we only have to know that we have the 3 trig ratios, and we must be able to see them if we are having a right angle triangle, and be able to apply them so that you can be able to have answers. For instance, let me just do a quick example. Maybe we are given triangle A, B, and C. No, this is not a right angle. It's a bit weird. Let me just do something like this. Okay. Better. Now we are given a right angle triangle like this. Then we are having theta here. We are also having 3. We are having x. We are having 5 here. Then for instance, they will say calculate the value of x. X, we know that according to the Pythagoras theorem, we know that r squared is equal to x squared plus y squared, having r squared to be 5 squared, and x squared is what we are calculating, and y squared, which is 3 squared. So in order for us to have x, we know that 5 squared, we transpose 3 squared, and we have x squared. We know that this is 25 minus 9 is equal to x squared. Then we only want x. We know that we have to apply the square root. We did solving for x last week. Then we have our x to be equal, because 25 minus 9 is 16, and the square root of 16 it's 4. So basically you calculate and you have your x to be 4. Then you can calculate the value of theta by using the trig ratios. So maybe you can say sine of theta is equal to 3 over 5, because the trig ratio sign is opposite over hypotenuse, and we want theta. So we're going to have theta is going to arc sine of 3 over 5. Then after that, you use your calculator, then you get your angle theta. So this was basically grade 10. Now, if you have any question, please don't forget to ask on the comment section. Please don't forget to ask on the comment section. It's so essential that you ask so that you can be able to help. You can also ask us in our WhatsApp group. We will always respond. Now, in grade 11 now, this is when it started to be core. In grade 11, first things first, we were taught about the reduction formulae. We were taught about the reduction formulae. Now, in the first quadrant, we always have 90 degrees, because this is 90 degrees minus theta. Theta is going to be our angle. And in this second quadrant, we have 90 degrees plus theta. And we also have 180 degrees minus theta, which means when we are reversing from the third quadrant, because here it's 180, we all know that a straight line is equal to 180 degrees. And when we divide by 2, we have 90. And when we divide here, 180 plus 90, we have 270. And this will be 360 degrees. So when we have 90 degrees minus theta, that's the first quadrant. We have 90 degrees plus theta. That's the second quadrant. Then we also have 180 degrees minus theta, which is in the second quadrant. So we have 180 degrees minus theta, which is in the second quadrant. Now, in the third quadrant, we have 180 degrees plus theta. We have 180 degrees plus theta, and we have 270 degrees minus theta as well, because when we reverse, go back, we have the negative. When we go forward, we have the positive. Then in the fourth quadrant, we have 270 degrees plus, and we have 360 degrees minus theta. Theta is our angle in this case. So now, we said earlier and we spoke about the trig ratios. Please be careful. This is the essential part of the trigonometry from grade 11. This is so important now. Bear in mind that now we have spoken about the trig ratios. So now we must allocate the trig ratios in the four quadrants so that we can be able to see where is this trig ratio positive. So in the first quadrant, all of the trig ratios are positive. So in other words, we say sine 90 minus, when we say cos 90 minus, when we say tan 90 minus, we're going to have a positive because we are under the reduction formula. So on the reduction formula, it is so essential, it is so important that you take note of this. In the second quadrant, only sine of theta is positive. In the second quadrant, only sine of theta is positive in the second quadrant. In the third quadrant, only tan of theta or tan of theta is positive. And in the fourth quadrant, only cos of theta is positive. Cos of theta is positive. So to just summarize what is here, we are saying that in the first quadrant, all the trigonometric ratios are positive. So for instance, if you are told to prove the identity or to simplify the identity, you must always know that if you are having sine cos 360 degrees minus theta or minus an angle which you are granted there, you use the reduction formula. And now we all know that when we are saying 360 minus, we know that that's the fourth quadrant and cos is positive. So you're going to end up having cos theta only. If you are having sine of 360 degrees minus theta, that will now lead to a negative sign because in the fourth quadrant, only cos theta is positive. So bear in mind that when we are having sine 360 minus, it's going to be negative. Now your result will be negative. So in other words, if you are given sine of 360 degrees minus theta, you end up having negative sine theta because it is in the fourth quadrant, and only in the fourth quadrant, only cos is positive. Other trigonometric ratios are negative. All of them are negative. Now, on the second quadrant, sine theta is only positive. So in other words, when we say tan 90 degrees plus theta, you're going to have a result which is negative. Because in the second quadrant, only sine of theta or only sine, which is the trig ratio, which is only positive in the second quadrant. Moving to the third quadrant, having tan theta there, only tan theta is positive. So bear in mind that if you have sine of 180 degrees plus theta, you're going to end up having, when you are done reducing it, you're going to have negative sine of theta. Now, moving forward now, In the fourth quadrant, only cos is positive. So that's what's important about the reduction formula. When we are told that this minus, you have to check these key values: 180, 90, and 360. 270 is not just really used so much, but you have to check always. Please do check that. Which quadrant are we dealing with in this instant? Now, I want to move, whilst I'm still on this case again, I want to have what we call complement. Not, sorry, it's corratios. I hope I didn't name them wrongly. If I did, please correct me. Now, on these ones, it's only takes place on sine of 90 degrees minus theta, sine of 90 degrees plus theta, and cos of 90 degrees minus theta, and cos of 90 degrees plus theta. So now, on the corratios part, when we say sine 90 degrees minus theta, what is important in order for us to have the solution here? We're going to look at what is inside the brackets first. So we are having 90 degrees minus theta. So we go back to our reduction formula, or our reduction cross. We have to look there. Where is 90 degrees minus theta? 90 degrees minus theta is in the first quadrant. And now we look on the trig ratio which we are given. So is sine of theta is sine 90 degrees minus theta positive in the first quadrant? Yes, it is positive. So its co-ratio, it's going to be positive cos of theta. So these ones are co-ratios because they are equivalent. Now, going to this second one, please don't forget to ask question in the comment section if you don't understand. Now, going to the second one, sine 90 degrees plus theta. The first thing we said, we look at what is in the bracket first. Then after that, we look on our reduction formula. So 90 degrees plus theta is in the second quadrant. Then now you are done. Now ask yourself, is sine positive in the second quadrant? Yes, sine is positive in the second quadrant, which means its co-ratio also is going to be positive. So we're going to have cos of theta. It can be theta, it can be x, it can be y, it depends. Theta is just representing an angle. Then moving now, we have cos 90 degrees now minus theta. Now we say we start by having what we have in the brackets first. So in the brackets we have 90 degrees minus theta. So 90 degrees minus theta is in the first quadrant. And now we look at the ratio which we are given. We are given cos. So now we ask ourselves, in the first quadrant, is cos positive or negative? Cos is positive. So which means its co-ratio is going to be positive. So in other words, cos and sine intertwine, they change when they go to 90 degrees. They always change. Now we have now cos 90 degrees plus theta. So we say the first thing which we do, we look at what we have inside the brackets. So in this instant, we have 90 degrees plus theta. So 90 degrees plus theta is in the second quadrant. Now, coming back again, is cos negative or positive in the second quadrant? Cos in the second quadrant, it is negative. Only sine is positive, which means its co-ratio is going to be negative. So the co-ratio of cos 90 degrees is going to be negative. Negative sine of theta. So far, is there anyone with any question? So this is basically what is so essential, so important when we look on our grade 11 trigonometry. Moving forward, we have what we call special triangle. Please forgive my handwriting. Okay. we have what we call special triangles. So now special triangles are these two nice, awesome triangles. Let me just write them here. (90°). Okay. (60°). 30°. Triangle A, B, C. Then you have this other one as well. 45° and 45°. So these are our special triangles. So now on the special triangles, this is your 2, this is your 1, and this is your √3. On this one, it's 1, 1, and square root of 2. So these are your special triangle. When you use your calculator and when you say, for instance, when you say sine of 45, it will give you √2/2. And that's obviously wrong. That's how they will see that no, you used your calculator, because there are those questions they'll ask you without using your calculator. Please simplify the following. So if now you have √2/2, they will definitely see that no, you used your calculator. So these are the special triangles. So these are our special triangles. So maybe let me just make a quick example. If they say sine of 60°, when we are using this reduction table cross as well, sine 60°, we know sine it's opposite over hypotenuse. So your answer must be √3/2. Number 2, maybe when they say tan of 30°, where is the angle 30°? This is 30°. So which one is our tan? We know that tan is opposite over adjacent. So the opposite one is this one, which is always, you see, when you look at our 90°, this is going to be the opposite one. So when we say tan 30°, we expect to have 1/√3, opposite over adjacent. So maybe let's come this side now. Let's say maybe you are having sine of 45°. Sine of 45°, we know that it's opposite over hypotenuse. So it's gonna be 1/√2. So these are our special triangles. I won't dwell much on this. Please, you must know this by head, because if you think you're gonna use your calculator in the exam, they'll give you wrong answers. So please be careful and be cautious when it comes to that. Please be careful and cautious when it comes to that. Now, we move forward now to what is called trigonometric identities. This is where our problems now and the heat starts now. So we have what we call trig identities. Trigonometry identities. Please be careful on these ones. These are important because trigonometry is all about these things. So everything which I'm telling you right now, which I'm tutoring you right now, is essential, as it's all cover to the work, and it's so important, it's so essential, so that you can understand the basic before you calculate your questions. So on the trig ratios, we have 1, we only have 2, but I created 4. We only have 2 in grade 11. The first one, we have tan of theta, which is always equal to sine theta over cos theta. It's always sine theta over cos theta. Always sine theta over cos theta. The second one, we have sine squared of theta plus cos squared of theta, which is equivalent to 1. So now I have 2.1. I created mine so that I don't have any problem. When you transpose cos squared to that side, you make sine squared of theta the subject of the formula, and we have 1 minus cos squared of theta. So in other words, in those proving question, when you see 1 minus cos squared of theta, that is equivalent to sine squared of theta. Trigonometry is made easy for you. Now let's go to 2.2. We have what we call, when you make cos squared of theta the subject of the formula, when I have cos squared of theta, which is equivalent to 1 minus sine squared of theta. 1 minus sine squared of theta. This is amazing. 1 minus sine squared of theta. So these trigonometric identities, they are so essential, they are so important. You have to know how to use them. When they say prove that the right hand side is equal to the left hand side, know that when you see tan theta, don't take much time. Just change it to sine theta over cos theta and use your algebraic skill so that you can be able to solve the questions. Your question. Okay, now we are done with these identities for grade 11. For grade 11 we're done. Now we're gonna go to the area rule. Calculating the area of a triangle. So for instance, we have this kind of triangle. Let's say A, B, and C. Let's say this one is C. Let's say this one is A. This one is B. Yes. Okay, yes. So the area rule says that the area of triangle ABC is equivalent to triangle ABC. So maybe you have this angle A, so it's equivalent to 1 over 2 AB times AC sine of angle A, the angle which you have. Come on, talk to me. It is also, if you are having this angle B, it's always 1 over 2. So we take the two sides which are embracing or which are covering or which are sort of like supporting the angle. So if we have the angle here, these two sides which are supporting the angle which we have here are the sides which we take into consideration, because these two sides are supporting this angle. So when we are calculating the area of that triangle ABC, we say area of triangle ABC is this half, this side times this side, then we include the included angle in between. So in this case, when we are having this angle B, so we're going to say half of AB times BC, then we say sine of angle B. The same applies if you are having this, let me just put a dot here. If you are having this angle C, which means these two sides are the ones which are important, so you can say it's 1 over 2 AC times BC, sine of angle C. So this is our area rule. It's so important. You're gonna see it when you're gonna do calculating the area, especially in the prop theorem in grade 12 Euclidean geometry. We're gonna go there as well. I think next week, if not this week, we're gonna go there. Where it's so important. The area rule is so important. When they ask you to calculate the area of this triangle, you see this one, it's not our normal triangle. We know that area of a triangle, area of a normal triangle, let me just use something different. Area of our normal triangles, a right angle triangle, this is going to be our base, this is going to be our height. So we know that area is half base times height. We know that where this is our height, when this is our perpendicular height, and we know this one. But now the area rule, now it's applies in this case, that we are given an area, a triangle. Maybe it's a scalene triangle, or maybe it's an isosceles triangle, maybe it's an equilateral triangle. Those are the three types of triangles. So if you are given those triangles without given a right angled triangle, you can be able to use the area rule so that you can be able to determine the area of that triangle. So we move from there. We have this nice thing which is called the sine rule. We have the sine rule. Sine rule. So for instance, maybe we are given this kind of triangle again, having A, B, and C. So this will be C, the opposite. This will be A, and this will be B. Now, let's say this is angle A, B, and angle C. So what is so important about this? You must be able to prove it. But since we don't have much time, we are not going to prove this theorem. Please just cram it when you're about to go to exam if you can. But I advise that you understand the concept beyond the sine rule, because you must be able to prove it. It's usually 5 to 6 marks when you come to your exam. It's usually 5 to 6 marks, yes. Now, on the sine rule, the sine rule is the easiest one. If you have two angles and maybe you have to calculate one side, you can just say, let's say sine of A over, this is our A. We take our A and we include our opposite. Come on. Oh, okay. Oh, I just did something wrong here. Just use that blue again. Sorry for the inconvenient. Okay. Now, when we say sine of A, this is our A. We take it with our small letter a. You see the opposite side. So we say sine A over small letter a is equivalent to, so when we take this angle B, so we'll say we have sine of angle B divided by, we do the same thing again, the opposite side of the angle which we are talking about. So this will be our small letter b. They are all equivalent. So we are left with sine C now. So when we have sine of angle C, we also take the corresponding, small side, which is small letter c. So we also take that. So in other words, you don't have to use three of them, but maybe you are told to calculate the value of A and you have both these values, so you can just use these two. Or maybe you are given these two, you can only use these two because all of them, they are equivalent. So it's essential that you know the sine rule and be able to apply the sine rule. Now, moving forward, are we together, guys? If we are together, just put put any emoji on the comment section if you are with me, if you are following with me, or you can ask any question as well. If you feel like you want to ask any question, you feel free to do so. Please do ask any question if you have any question. Okay, now we move from the sine rule. We're now moving to the cosine rule. You must know these things because there are those questions in grade 12 which comes whereby you have to prove that this, maybe they'll give you, for instance, we're doing this question on, which I uploaded on Facebook, that you're saying that prove that AB is equal to a square root of 25 minus 13h squared cos x, I think so. Yeah, some that kind of equation. So you have to know the cosine area rule as well as the sine rule. They will assist you to be able to solve this kind of question. So on our cosine rule, we still have our triangle A, B, C. So the opposite of A, it's A, small letter A. The opposite of C is small letter C, and the opposite of B, it's small letter B. So now moving forward from that, so the cosine rule, if we want to calculate this side, so this is our angle which we'll be dealing with. So this angle is supported with these two sides. So in other words, angle C, because we want to deal with small letter c, or we want to deal with AB, we want to calculate the side of AB, having AB like that. So we are having sort of like this triangle, we are having C here. So we take the supporting sides, these two are the supporting side, and now we'll be able to calculating the best one which we want. So for instance, this one we want C We want to calculate the side of C. So C squared is always equal to these two, which are supporting the angle. A squared plus B squared minus 2AB cos of angle C. So this is the cosine rule. This is our cosine rule. This is our cosine rule. Then we have A squared. If we want to calculate this side A squared, we know that this is our angle. So now it's already a jump case that here we're going to have cos of angle A. So this cos of angle A is now already here because we are calculating its distance. So the moment you calculate, the moment you put A here, which means you also have to cos A. Now, what is supporting this angle A? It is being supported by C and B. So we're going to have B squared plus C squared minus 2BC. So you multiply the side, the adjacent side again, and cos of A. Then we move from that, we go to the last one, which is our B. So this B is in conjunction with B, big capital letter B. So when we are having to calculate that side AC, we calculate the AC, which is B, which means already here must have cos of angle B. So angle B is supported by two sides, A and C. So that won't be hard because we know that this angle is supported by these two, supported by these ones. So we can just write A squared plus C squared minus 2AC cos of B. So this is our cosine ratio. This is our cosine ratio. We are about to go to questions now. I am done with the trigonometry of grade 11 now. I'm done with everything. We started by talking about the reduction formulae. We did the core ratios. We did the identities. Now we also did the area rule. We also did the special angles. We also did the sine rule. We also as well did the cosine rule. So that's our grade 11 stuff. That's our grade 11 work. And that we are done with the trig of grade 11. I'm giving you an overview so that when we are working on questions today, we will understand and be able to cruise together in our questions in a smooth way. Now, let's go to grade 12 now. Grade 12 trig. Grade 12 trigonometry, we taught about the compound angles. So on this one, first one, we have sine of A plus B, which is equal to sine of A times cos of B plus cos of A times sine of B. Then number 2, let me try to write small red letters. Sine of A minus B is equal to sine of A times cos of B minus cos of A times sine of B 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 times sine of B. Okay, let's move forward. We have cos of A plus B. So on the part of cos now, that's where we have a small changes. We have cos of A times cos of B. If it's plus, it's going to be minus this side. If it's plus, it's going to be minus this side. If it's plus, it's going to be minus this side. Then we have our sine of A times sine of B. Then we move from there. We have cos of A minus B. So cos A minus B, it will be cos of A times cos of B. Since it's minus, it will interchange and it will be plus sine of A times sine of B times sine of B. So these are our compound angles. They are so important. They are so essential. We're going to do examples also on this part. We're going to do as well more examples on this part. We're going to do examples and we're going to do some workings from 7 to 8. We'll be doing calculations, calculating this trigonometry till maybe we'll finish it next time. Now, the other part which is essential in trigonometry in grade 12, you were taught about what we call double angles. They are identities. Let me just say identities. We taught about double angles in grade 12. Remembering them, we have, let me start by sine 2 theta, which is equivalent to 2 sine of theta times cos theta. This is our double angles, double identities. Let me just say, right, double identities here. This is our double identities. Double identities. We have sine 2 theta, which is equal to, or which is equivalent to 2 sine theta times cos of theta. Then number 2, this one, cos 2 theta. Let's say number 2.1, because cos 2 theta, the double angle of cos 2 theta, it has 3 expressions which we can be able to express it. So the first one is 2 cos squared of theta minus 1. And the second one, 2.2 cos 2 theta, it is equivalent to 1 minus 2 sine squared of theta. Then the last one, which is 2.3 sine of 2 theta, sine of 2, okay, cos of 2 theta is equivalent to cos squared of theta minus sine squared of theta. So these are our double angles. These are our double angles. So I am done. We have trig graphs. Now trig graphs, we'll do them next time. Let's end here. Let's end here for today. We will do trig graphs next week. This week or next week, I'm not sure, but we'll see. But we'll do trig graphs next time. It's not they're not hard. I'm gonna cover them when I'm covering functions. I think on Thursday. When I'm doing functions. Now we are done with everything which we have done on trigonometry. We are done with everything. We are done. Is there anyone with any question now, guys? Please don't be afraid to ask any question. I'm giving you 2 minutes to ask any question. If you have, you can ask on our group. We are also willing to answer them. You can ask on the comment section. Please do ask now, because we are about to go to do question papers now. We're about to revise now. We're about to do something which we can practically see. I want to do some things which we can practically see now. So please, if you have any question, please ask. If you want more explanation on something, please, you might as well ask. Still have time. 1 minute left. 1 minute left, 1 minute left, 1 minute left, 1 minute left, 1 minute left. Now, if you have any question, please do ask. If you have any question, please do ask. If you have any question, please ask. So to summarize what we did today, we started from the start and we started to do the grade 10 trigonometry, and we looked in few things in grade 10. We looked in about the first one, which we looked at our trig ratios. And after we are done with our trig ratios, we moved there and we went to grade 11 stuff, and we did the reduction formulae. We did the co-ratios. We did the area rule. We did the special triangles. Now we are doing questions now. Seems like no one have any question. So I think we can kick the ball and start going now. I think we can start doing some questions now, if no one has any question. If no one has any question. Okay. If anyone doesn't have any question. Now, we are having this question which is on the board, which is adapted from the grade 11. I'm gonna go as well and do grade 12. This is our question, which is nice, which is sweet, which is nice and sweet, which is great. Now, question 5, they are asking us to prove. They want us to simplify. Sorry, first they want us to simplify. They want us to simplify. Fully sine 90 degrees minus x. Let me just write question 5 here. Question 5. They want us to, okay, to simplify. Okay. 5.1. Simplify fully sine of 90 degrees minus x times cos of 180 degrees plus x plus tan x. Okay, I'm writing the equation on the tablet so that you can see. Sine of 90 degrees minus x times cos of 180 degrees plus x plus now tan x times cos x times sine of x minus 180 degrees. And it's 6 marks. So now, let's do now. Let me just draw something so that I can remind some few. So we said first thing, if you're given this kind of question so that you prevent you from getting trouble, you have to have this. If you don't know it by head, of course. So we have our 90 minus x, because we're talking about x. We have our 90 plus x We have our 360 degrees plus x. We have our 360 degree, 180 minus x. We have 180 degrees plus x. We have 360 degrees minus x. We say that 270, we don't normally use it. It's not important. It's not normally used, gets used. Because x, here all of them, here only sign is positive. So now we are simplifying our question now. They're saying that simplify fully sine of 90 degrees. Simplify fully sine of 90 degrees minus x times cos of 180 degrees plus x plus tan x times cos of x times sine of x minus 180 degrees. Minus 180 degrees. Let's simplify together, guys. This is how you get marks. It's easy. This is how you get marks. Now, let's start with sine 90 degrees minus x. Earlier on, we have spoken about corratios, and we say that sine 90 minus or plus and cos 90 minus or plus, they interchange when we are given that ratio. So in this case, we're given sine 90 degrees minus x. So sine 90 degrees minus x, we say the first things which we look at when we are solving this question, we look on what is inside the brackets first. Okay, so we're having 90 degrees minus x. Since me, I'm slow, I decided to draw I decided to draw my cross. So on my cross now, 90 degrees minus x is in the first quadrant. And how is sine in the first quadrant? Sine is positive. So which means that the co-ratio of sine is also going to be positive. Let me just write solution here. So we're going to have positive cos of x. Then we move here again. Now we are going to cos 180 degrees plus x. We said what is important is we have to look on what is inside the bracket. So inside the brackets we have 180 degrees plus x. So 180 degrees plus x is in which quadrant? It is in the third quadrant. This is how you solve it. This is how you do it. This is the strategy which you use. Then after that, in 180 plus x is cos now positive or negative. Now, in our third quadrant, only tan is positive. So other trig ratios are negative, which means you're going to have negative cos of x. So in other words, we have reduced it. Hey, we have reduced everything. We have reduced it and removed that 180, and we are only left with the angle. Now, moving forward to plus tan x. We know that we did identities together. We are applying everything which we have done. So we did identities earlier today together. So now what is important is that on the important side of tan x, we're just going to replace tan x and put the identity sine x over cos of x. Now, moving forward, you multiply by cos of x and we multiply by, now we are given sine of x minus 180 degrees. So now sine x minus 180 degrees is in which quadrant? So when they give us something which is negative, which means we are going like this, we're going like this, and we're going like this. Or in order for you to not to be confused, sometimes I also advise that you can just say, let me just read something which is different so that you can see. Use something like black. Okay, so maybe in this instant we are having sine. We want to see if we can solve this in a way that which is appropriate and something which we'll be able to understand. So if we say something like this, for instance, this and this, they are equivalent, because when we say negative times 180, we get negative 180 degrees. Negative times negative x, we get positive x. So basically now when we say sine 180 degrees minus x, this is the way which we understand. This is the way which we know 180 minus x is in the second quadrant. So we're going to end up having negative, then this is going to be still positive now. So we multiply now by the exterior angle which we had the negative sign, then after that the two go together with each other. So now we're going to have times negative sine of x. So as I said, if you get confused or if you can't do like this, because this is 0, this is from 92, then this 180, and x minus 180 is here, and in this quadrant sign is negative, because when we are moving backwards, guys, we are saying from this is going to be x minus 90, x minus 180. So x minus 180 is in this third quadrant, and we know that in the third quadrant only 10 is positive. So in that case, since 10 is positive alone, we have to change that one now. It's going to be a negative sign. So you can also do it in this way. If you can't understand it in the reversing order, you can just make sure that you have sine 180 degrees minus x, and you make sure that the scalar multiplier which you have outside is going to be able to give you the same output when you return it back to the original thing in which you are given. So we are having this. Now let's solve now. Cos x times cos x, we know that x times x is x squared, so it's just the same. So we're going to have cos squared of x. Don't forget the sign, negative cos squared of x, plus we know that this and this will cancel, because in other words they are just dividing these ones. Since we are multiplying all along, they will cancel each other, and we're left with sin x times negative sin x. Then we have negative sine squared of x. So this is step 2. Then now the last one, now we see that we can have a identity here, cos squared of x, plus when we have negative 1 as our common factor, we're gonna end up having cos squared of x plus sine squared of x. And cos squared of x plus sine squared of x is the same as 1, because it's an identity. Then negative 1 times 1, you end up having negative 1. Wow. So our final answer is negative 1. Our final answer, it is negative 1. Our final answer is negative 1. Let me start again so that we go together. So first things first, which I did in this question, I read it that we are given sine 90 degrees minus x times cos 180 degrees plus x, plus tan x times cos x times sine x minus 180 degrees. Trigonometry is nice. This is where you have to catch those marks, because on our paper 2, 40 marks is coming from trigonometry, and it's there, and 50 marks it's on Euclidean geometry, and 40 marks is always coming from analytical geometry, and 20 marks comes from statics. So you have to get those marks. You have to get those marks on trigonometry. Trigonometry is nice. It's not hard. Everything, you have them. You have to apply everything at the same time. Okay, now sine 90 degrees minus x, we know that when we have sine 90 minus or plus and cos minus or plus, we know that those are called co-ratios. So as I said earlier on, that when you are having we use the reduction formula. So since I am slow, so I advise, if you are slow as me, you can just write this. If you are someone who take it slow and might forget, I advise you, when you just go to your exam, just write this across this reduction cross. Then after that, you write the number, so that you know that in the second quadrant this trig ratio is positive. In the third quadrant, this trig ratio is positive. In the fourth quadrant, this trig ratio is positive. In the second quadrant, this trig ratio is positive. So we are having this one. So now we say that the first thing, step number 1, we look on what we have inside the bracket. So in this case, we have 90 degrees minus s. So you ask yourself now, where do we find 90 degrees minus x? 90 degrees is in the first quadrant. So now you come now to the trig ratio and ask yourself, is sine positive or negative in the first quadrant? And we know that sine in the first quadrant, it is positive. So if since it is positive in the first quadrant, don't mind, you know that the co-ratio of sign is cos of x, which is positive. So please bear in mind, please know that the sign, they always have to interchange. It's always the case that those two interchange. It's always the case that they interchange. You come into the second one, cos 180 degrees plus x. So this part which is written 180 degrees plus x, this is the first thing we ask ourselves. Where is this angle 180 degrees plus x? 180 degrees plus x is in the third quadrant. So you ask yourself those simple questions. So since it is in the third quadrant, now you come back and ask yourself, is cos positive or negative in the third quadrant? No, cos is negative. So that's why we ended up having a negative cos here. Negative cos. Then you say plus. Now we are given tan of x. We know that tan of x is an identity, which is say tan of theta is equal to sine theta over cos theta. So we apply the identity because we are trying to simplify. We break down and we simplify in the process. So tan of x now is gonna have sine of x over cos of x. Now moving to cos x, it's still there, we can't change that. Then on sine x minus 180 degrees, this is now something which is also important now. So in other words, we are going in the reverse direction now. As we were saying 90 minus x, now we are now saying x minus, so this is x minus 90 degree, okay, x minus 90, this is x minus 180 degrees, this is x minus yeah, it's going direction x minus 270, then x minus 360 degrees. Move that. Yeah. So x minus 180 is in the third quadrant. So now you ask yourself, is sine x minus 180? So you ask first, x minus 180, which quadrant it is? It is in the third quadrant. Now you come back now to sine. Then you ask yourself, is sine positive or negative in the third quadrant? Then you say, no, sine of x is negative in the third quadrant. So that's why we ended up having negative sine of x. But if you can't be able to understand the reverse, or maybe you get confused, you can solve it in this manner, that you know that you always start with numbers. So when we say, you just have to take the common factor, maybe to be negative, to be outside, to be the scalar multiplier. So negative 1 times 180, we're going to end up having negative 180. When you say negative 1 times negative x, you have positive x. So this is equivalent to this. Then we can say now sine negative open bracket sine of open bracket 180 degrees minus x. Then we start by what we have in the bracket. Where is 180 degrees minus x in our reduction cross? It is in the second quadrant. And in the second quadrant, is sine positive or negative? It is positive. That's why we inside we have our positive sine of x. Then we say negative times positive sine of x. Then we end up having sine of a negative sine of x. Then coming back now to what we have here now, then now we know that this and this will cross and cancel each other because they are like terms. It's in a matter of like just x divided by x. We know that we cancel these two out because they are the same, they are like terms. Then we have our negative sine x that side. So when we say sine x times sine x, we have our positive, our negative sine squared of x. Then we come here, and after that we see that there's a chance that we can have an identity, and we know that our identity, no man, we have this nice identity which says cos squared of x or cos squared of theta plus sine squared of theta. It has to be always equal to 1. So now we have to take our common factor there, and our common factor is negative 1. So when we take our common factor, which is negative 1, out, we're gonna end up having positive cos squared of x plus sine squared of x. Then after that, we know that this is an identity. Then cos squared of x plus sine squared of x is equal to positive 1. So negative 1 times positive 1, and we end up having negative 1. Then you are done solving your question. Is there anyone with any question? Is there anyone with any question when it comes to this instant? When it comes to this instant, is there anyone with any question? Come on, talk to me guys, come on, talk to me. If there is no one with any question, let's now proceed. Trigonometry is nice. It's really nice. Really nice. Really nice. Now, prove without using a calculator. Underline those words, without using a calculator. The moment you see they say that without using a calculator, know that we are going to use our special angle, special triangle. Special angle triangle. So now let me write it. Prove, come on. Okay. Prove without using a calculator that, okay, 5.2, prove that sine of 315 degrees times 10 of 210 degrees times sine of 190 degrees divided by cos of 100 degrees times sine of 120 degrees is equivalent to negative square root of 2 divided by 3. So we have to prove that our right hand side is equivalent to the left hand side. This is nice. This is nice. Now, the first thing which you have to write now is that we have to know that which side are you proving. So in this instance, we are proving the left hand. So you write your left hand side is equal to sine of 315 degrees times 10 of 210 degrees times sine of 190 degrees all divided by cos of 100 degrees times sine of 120 degrees. Look at the things which you are about to do now. Look at the things which you are about to do now. Nice things. Now, we know now, the moment they said without using a calculator, that is something which helped us a lot in a sense that we know that we have to use this nice triangle. We have to use our triangles. Change that pen. We have to use these triangles. $60 degrees, 30, root 3, 1 and 2. Then we have this one, which is 45, and 45, and it's 1 square root 2. Then we also have to use our reduction cross. It's also as well important. It is so much important. Now, let's attack this question now. Let me put the cross since we are still trying to get used to the cross. Let's put the cross. This is our cross. Let me just write it in a sense that it's better. This is our cross. We know that all of them, they are positive in 90 degrees minus x. We know that this is 360 degrees minus x or theta. This x or theta is representing an angle. Then here we can just write, let's write cos of x. Here we know that it's 180 degrees plus x, and we know that this quadrant is for tan of x. Then we know that this one is 180 degrees minus x, and we know that also 90 degrees plus x, and sine of x is positive. Then this is our reduction formula. Now, be careful now, and please listen carefully. Now, let's start now. On our left hand side, let's just say equal to, go back to the originality, equal to sine of 315 degrees. 315 is in which quadrant? We know that this is 90, this is 180, this is 270, and this is 360. So we know that 315 degrees is in the fourth quadrant. Because in the fourth quadrant, it consists of numbers which are between 270 and 360. So now, we know our special triangles that we have 45, 30, and 60. So we have to use them. So how are we going to use them in this instance? Sine of 350 degrees. We say 350 degrees is in the fourth quadrant. So we have to know that already we must have sine of 360 degrees minus. Then now we have to use these special angles which we have. We have 60 degrees, we have 30 degrees, and we also have 45 degrees. So when we say 360 degrees minus what, do we get 315? So in other words, let me just write something small here. We are saying that 315 degrees minus this, it must give us 360 degrees. So we have to calculate for this missing box. Okay. Or just to make things easy for you, we say that since 315 degrees is in the fourth quadrant, we know in the fourth quadrant is 360 degrees minus. So we're just going to say 360 degrees minus x is equal to the 315 degrees. So now so now we want the value of x here, which will make this equation balance on both sides. So when you say 360 degrees, you use your calculator, minus 45 degrees, we get 315 degrees. So now we only use these three special angles, 30, 60, and 45. So please be aware of those. So now let's fix our error. Let's fix our error here. So it's gonna be sine 360 degrees minus 45 degrees times. Now let's go to 210. 210 is in the second quadrant, because second quadrant consists of 180 degrees plus. So we already gonna write tan of 180 degrees plus. So when we add 180 degrees plus, which special angle do we get? 210 plus 30 degrees, we get 210 degrees. We see, we are already solving it. Simple like that. Then we go to sine 190 degrees. Sine 190 degrees is in which quadrant? It is here, because 190 is in third quadrant. So in third quadrant, we say 180 degrees plus. So what we're going to have here, we're going to have multiplied by sine of 180 degrees plus what? Plus 10 degrees, because 190 degrees minus 180, we get 10 degrees. So it's going to be 180 degrees plus 10 degrees. So after that, we divide everything. Now let's go down on our denominator. Of course, 100 is in the second quadrant, because second quadrant they have 180. They have numbers between 180 and 90 degrees. So we're gonna end up having cos of 90 degrees plus 10 degrees times sine 120. 120 is in the second quadrant, so we're gonna have our sine of 180, because we know that in the second quadrant it's always 180 degrees minus 180 degrees minus what, so that we can get 120 minus 60 degrees. So we only use these four special angles, no, 3, 45, 30, and now we can now simplify. Come on, let's go. Sine 360 degrees minus 45, we said we start by what we have inside the bracket. So 360 degrees minus 45 is in which quadrant? It is in the fourth quadrant. And is sine positive or negative in the fourth quadrant? Sine is negative. So we're going to have negative sine of 45 degrees. Last time we were putting x there because that was the angle. In this case, the angle is 45 degrees. Epic. Now let's go to tan 180 degrees plus 130. We say we start with what is inside the brackets. Let's call it 180 degrees plus 30 degrees. 180 degrees plus the angle. 180 degrees plus the angle is in the second quadrant. So since they are in the second quadrant, we know that tan in the second quadrant is positive. So we're gonna end up having positive tan of 30 degrees. Then times. Then 180, come on, we are given sine of 190 here. Sine of 190 is in this second quadrant, and we know that is in the third quadrant, sorry, and we know that in the third quadrant is 180 degrees plus 10 degrees. So sine 180 degrees plus 10 now. So we said we start with what we have in the brackets, which is 180 degrees plus 10. And when we start there, we will see that, no, man, our sine is negative in the third quadrant. Only tan is positive in the third quadrant. So we're going to end up having negative sine of 10 degrees. Now let's go to cos 90 degrees plus 10. The moment you hear cos 90, the moment you have sine 90, know that those are co-ratios. Please don't forget to intertwine, to interchange those two, because it's essential for you. So cos 90 degrees plus 10 degrees, cos 90 degrees plus 10. So we say we start with what we have in the brackets. So 90 degrees plus 10 degrees is in which quadrant? It is in the it is in the second quadrant. And how is our cos in the second quadrant? Our cos in the second quadrant, it's negative. So we're going to end up having negative sine of 10 degrees. Ooh, this is nice. This is nice. This is nice. Okay, let's move forward now to the last one. Sine 180 degrees minus 60 degrees. Let's look. 180 degrees minus is in the second quadrant. And is sine negative or positive in the second quadrant? Sine is positive. So since sine is positive in the second quadrant, we're going to end up having sine of 60 degrees. So now let's solve now. We know that okay. We know that these ones will cancel each other because they are the same. Then now we are left with negative sine of 45 degrees times tan of 30 degrees divided by sine of 60 degrees. Now we can use our special triangles. So sine of 45 degrees, we know that sine of 45 degrees, where is our 45? This is our 45 degrees. We know that it's opposite over hypotenuse. So we're going to end up having negative 1 over square root of 2 times tan 30. Let's go to tan 30. Where is 30? This is 30. It's opposite over adjacent. Opposite over adjacent. Please don't forget that it's so important. So we have opposite over adjacent that side. So we're going to have 1 over square root of 3. Then sine of 60 degrees. Sine of 60 degrees. We come back again to our special triangle. Sine of 60 degrees is root 3 over 2. Root 3 over 2. Now let's go. Negative 1 over root 2 times root 3. It's going to be 6. Because root and root, they cancel each other. Then we'll be left with 2 times 3. Then we have, I think it's going to be 6 there. Then it's dividing by root 3 over 2, which is the same as negative 1 over 6, then times 2 over root 3. Am I right? Yes, I think I am right. You can also, as well, on that point, you can be able to use your calculator if you want to use your calculator. You can use it at that point. But let me just double check on my calculator here if I am on the right track. Check. Okay. Check also on my calculator. Please check also on your calculators, and you can post on the comment section or on the group. Please check if we are on the right track together. If we are on the right track together. If we are on the right track together. Yeah, then you can use your calculator, because I do not need to continue because we can solve it, but you can use your calculator at this point. I think you have to get negative root 2 over 3. You have to get root 2 over 3. Then you are done solving. So this is our question now. So this is how we started it. We started by expanding it and including special angles. Then after that, we solved our question. Then then we were able to go until we solve it in this way. Is there anyone with any question? I think I'm gonna do one last question right now in this kind of manner of proving. Then when we meet next time, I think on Thursday I will be doing paper 1. But when we meet, I think I'm gonna try to have another session during this week, maybe Friday, or yes, then we can proceed as well and finish our trigonometry. Let's do this one last challenging question now. So we say it is equivalent to the right hand side, because we have proved that the left hand side is equal to the right hand side. Now 5.3, we'll do it next time. Let's do prove the identity. This one, let's do this last question for today. Let's do this last question for today. The next time when we are doing part 2 of trigonometry, I think on Friday later again, I'm gonna try to do trigonometry part 2, so that we can finish and cover everything now, because we'll be doing functions and Grade-Hof trig as well, the questions with double angles and area rule. So now let's do the last one, which is 5.4. Now they told us to prove that sine of theta minus tan theta times cos squared of theta all over cos theta minus 1 plus sine squared of theta is equal to tan theta. It's equal to tan theta. Now, so now we are given this question. This is our last question. This is our last example for today. Please forgive me. This is our last question for today. Due to time, this is our last question of today. Now, on this question now, we have to, they said prove the identity, right? So we have to write right hand, left hand side, the one which we're going to prove, that sine theta minus tan theta times cos squared of theta, all divided by cos of theta minus 1 plus sine squared of theta. So now let's go. So wherever we see identities, we change everything. Come on, let's go. Sine of theta minus, we know that tan theta is the same as sine theta over cos theta times cos squared of theta. Then we know that we still have cos theta minus 1 plus, we know that sine squared of theta is the same as 1 minus cos squared of theta. So we change this. Let me just put them in brackets. We change these two because this is an identity, and tan theta as well is also our identity. So now let's go. Sine of theta minus this cos and this 1 cos will cancel. Then we'll be left with sine theta times 1 cos theta only now, because this cos squared theta is the same as cos theta times cos theta. Then we divide all through by cos of theta minus 1 plus 1 minus cos squared of theta. Come on, we are almost done. This is nice. Then we know that negative 1 plus 1 is equivalent to 0. Then our common factor on the top is sine of theta. Then it's gonna leave us 1 minus cos of theta. We are applying what we learned about solving for x. We have a common factor on top, so our common factor there is sine of theta. So we're gonna end up having sine of theta as a scalar multiply outside, since it's a common. Then after that we're gonna solve. And also on the base we have cos theta and cos theta this side, and we know that negative 1 plus 1 is equal to 0. So having our cos theta as our scalar multiplier as our common factor, we're gonna end up having 1 minus cos of theta as 1 minus cos of theta. This is nice. They are common. We cancel them out. Then after that we end up having sine of theta over cos of theta. Then now we know that this is an identity which is equivalent to tan of theta, which is equivalent to our right hand side. Which is equivalent to our right hand side. Then we saw that our left hand side is equivalent to our right hand side. So today we did our trigonometry, and I've given everyone an overview, and we did 3 examples, 3 questions. This is our part 1. I believe on Friday at this time at 6 p.m. as well, we're gonna try to have part 2, or we arrange time, and we're gonna try to have our part 2 there, so that you can know. Now we'll be doing questions, combining all the question papers, and we can solve the problem. So please, the way we solved this one, it was easy. Where we see identities, we change them, and after that you can be able to solve the trigonometry of grade 11 and grade 12. They are the same. In grade 12 they just add the compound angles only. Other than that, they are the same. So please go through this streaming video. Go through and redo these examples, redo like the way I was doing, so that you can have correct answers and get used to solving problems. Till next time, we're gonna meet on Wednesday. There is physics on Wednesday. Please do attend. It's going to be at 15:45 p.m. Please do attend. It's gonna be physics with prof or the professor on Wednesday. On Thursday, to be me on 15:45 as well. We'll be continuing with our paper 1. Catch me for functions in maths. We'll be doing our functions in grade 12 and grade 11. Linear functions, parabola, hyperbola, and we also touch calculus. Then on Thursday, please, on 15:45, on Friday, sorry, on 15:45, we're gonna have a session with Dr. Nyasha. He will be taking us for chemistry, for physical science. So everything is there for you. Please do attend the sessions. Please don't forget to subscribe, comment, and like on our page. Till we meet on Wednesday, have a great evening, and may God bless you all.